Welcome, everyone. Thank you so much for joining today's webinar. While we are letting everyone in, I'll quickly introduce myself and show you on Acelab where you can learn more about ballistic glass. My name's Kayla. I'm here from the Acelab team, and we have Hunter, who is presenting today from the ballistic glass team. All right, so let me quickly show everyone where on Acelab you can learn more about ballistic glass. All right, so here I am on Acelab's website. When you first log into Acelab, you'll see here a search bar at the top. You can search in ballistic glass. From there, you can scroll down their page to learn more about them, where they ship to. You've got some contact information for Hunter right here if you'd like to get in touch with him after today's session. You're also going to have a full list of their products for you to explore as well. You can click into any one of these to get more details. Go ahead and save it to your firm library for future reference. Definitely encourage you to do that. And we've also got some inspiration photos as well down here. So I will share a link to their page on Acelab in the chat. I will also I want to go through a few other things to make note of before we get started today. We do have a Q&A for you. So at the bottom of your screen, you'll see a Q&A button. You can drop any questions in there throughout today's webinar. Towards the end, we will read out loud some of those questions and Hunter will be able to answer for us. You'll also see a poll come up during the webinar, so we encourage you to fill that out for us and a survey towards the end. So I think that's everything. I'll go ahead and pass it back to you, Hunter, if you'd like to get started.
Okay, thank you very much, Kayla. My name is Hunter Payton. I am Director of Sales for Ballistic Glass and Armor Solutions. We're in Dallas, Texas. Today we're going to be discussing school security glazing and what lies in there. So let's dive right in. All right, so for the agenda, we're going to give like a market context. A lot of what we're going to be talking about are testing standards, which is really one of the things that has been lacking in the understanding of using protective glazing in the context of forced entry rather than ballistic. Ballistic is fairly well understood, but forced entry is not. So that's the main thrust of what we'll be going over today. And of course, talking about our products. Okay, so market need. As we all know, unfortunately, over the last 20 years, these instances have been rising more than anyone would like, taking sharp turn upward in the last 10 years. There have been a number of different responses to this, from security guards having policemen on site, but one of the most addressed issues was just keeping people out of the school. And that's been done from ballistic and forced entry. And that's where the market has been heading. So on the market trends, with that number going up, there's obviously going to be a lot of people getting into the market to discuss the different types of and implement the different types of solutions that people are coming up with. One of the first ones was film, and then laminated security glazing really didn't take hold until after Sandy Hook. There are all kinds of new players in the market all the time because this is becoming a $1 billion plus, $3 billion plus industry. So it's important to understand from the perspective of schools and people who are specifying these products, just what they're buying and just what their capabilities are. And again, that's what we're mainly going to be focused on today. So what you see there is a picture of the window that Adam Lanza went through at Sandy Hook. This picture always really drives it home just how important it is to protect the glazing in schools with laminated glass to keep people out, because the school designs are always trying to let the most amount of light in. And while that is wonderful for a learning environment, it's, terrible from a security perspective. So you can have locked doors, you can have anything you want, but if you've got, uh, a huge piece of tempered glass right to the right of that, they can go through that pretty quickly. Um, when looking at this, schools and people, the architects, everyone needs to balance risk tolerance and budget. And I use that term a lot when I'm talking to my clients because there isn't a national standard. There are test standards, and some states have uh, gotten out and done some things with film. Some are more focused on specific test standards, but there really isn't a national, local, or even local level standards. So really, it's about identifying and understanding the solutions and again what they're capable of. So there are really two types of protection when we're talking about glazing. I'm repeating myself here, but you've got ballistic. On the left there, that's a picture of Nashville, um, where that assailant went through to get into the school, going right through tempered glass. And then forced entry, which typically does not have any ballistic capabilities, but one of the market trends that I'm seeing is that rather than protecting, like an area like you see on the left with, say, a level 3 UL ballistic, which we'll go over in a second, say secure vestibule, those are expensive and they're point specific. Whereas forced entry glass can be put all over first level glass. They can be put in the doors. It's an easy retrofit application. You don't have to tear out the doors. And while you're not protecting necessarily from, gunfire, what you are doing is keeping the would-be assailant on the exterior of the building, which goes a long way towards reducing the risk of there being a mass casualty event. These things are usually over in 6 minutes or less, and they're just not getting through this type of glass in that time frame, which allows the authorities to come and take care of the problem. Okay, so when we're talking about ballistic standards, whether whether you're specing for a school or something else, it's really important that you understand what it is that's being specified. As a running the sales end of my company, I see all kinds of specifications that don't make sense, things that are incongruent, just a lot of cutting and pasting happening, frankly. So understanding what it is you're buying and what the capabilities and drawbacks of those products are is very important. So levels 1 through 3 on the UL 752, which is the governing standard for ballistic applications in this country. Unlike, we'll get into this in a second, but unlike forced entry standards, the UL 752 is the standard. There really isn't another one. And so it's pretty clear when things are being asked for. If you say level 3 ballistic, it's UL level 3 ballistic. So levels 1 through 3 are handgun protection, and above that is rifle protection. Most commonly, you will see handgun protection, specifically level 3, specified in schools. The reason for that is it's about the most protection you can get before you really jump up in cost and installation complexity. Um, Anything above that, the glass starts to get extremely heavy and extremely expensive. So level 3 is kind of where both the scholastic and architectural community settled, is what we're going to go with level 3. But as I said, I'm seeing a lot less of that in the market on these secure vestibules in favor of forced entry glass, just because it's so much less expensive and you can get so much more real estate on a school for the same price as you could a level 3 vestibule. Okay, dovetailing with ballistic protection. When you were talking about ballistic protection, it is important to understand the difference between low spall and no spall glass. It has nothing to do with the ballistic capability of the product. What it has to do with is the composition of the laminate. So no small glass has a hard coat or abrasion resistant polycarbonate to the interior on surface 2, which would be considered the secure side rather than the attack side. And when the glass is shot, there is no glass spray that comes off the back of that glass. Whereas low spall glass has the polycarbonate to the interior of the laminate, making the attack side or surface 1 glass, with surface 2 or the secure side being glass as well. Why that's important is it depends on where you uh, decide to put the different types of glass. So if you've got somebody's eyeballs that are going to be right behind, a transaction window, guard shack, some kind of enclosed space, you want to use no spall glass. Now, if you're doing something that is the front of a school, something that's going to have writing and poster boards and signage, you want to use the low spall glass because it's got the glass on the back side. The reason for this is even though the hard coat polycarbonate is a hard coat, it's really not that hard. It can be damaged both physically and chemically. And the risk of having to replace very expensive pieces of glass in a school are such that we hardly ever see schools specifying no spall glass, but it's important that it's understood that that is what's being specified on the low spall so that everyone from the district understands, the architect understands, the glazer understands what the drawbacks and benefits of each one are. So this leads us to forced entry testing standards. As I said, unlike the UL 752, forced entry has been the Wild West. There are so many forced entry tests out there that it's really hard to make sense of which one to use, or historically has been anyway. Their old HP White test, which was the gold standard forever, but they've been out of business for 5 years now. They're European standards. There are older ASTM standards. Um, and there's different testing methods. Is it a timed test? Is it a series of implements? It just makes it very difficult to figure out which standard we should go with. Recently, the ASTM, and this is what we're going to be talking about a lot. It was released in 2022, September of 2022, released the ASTM F3561. They did this in conjunction with the NGA, and the effort was done to try and bring order out of chaos of what I was just talking about. And not just from a perspective of which test to use, but all of these other tests, other than the F3561, are human error tests or manual tests. So it's just some person swinging something at a piece of glass or filmed glass or whatever it is, but it's a series of implements and with a number of strikes. And so that's how they determine the test, which you're going to have, even if you had the same person doing that test on a day-to-day basis, it's not going to be congruent. They're not going to hit the glass the same way every time. You're going to have variation, which gives incongruity in the market as to who's passed what and who hasn't. Uh, the STM 3561 uses a 100-pound pendulum to strike the glass. So you're getting the same results every time. Doesn't matter which lab you send it to. Doesn't matter what time of year it is, how tired the person was when they woke up that day. It's always the same. And one other thing I want to touch on, a lot of people put in to their forced entry literature, they give very definite time markers. Most of these tests, like I said, are not tested to time marker. It is implements and number of hits per implement. Now, you can say it's a 6-minute glass, but that's an extrapolation because That's not how the test is conducted. There's just something to be aware of because I get asked all the time, will this glass hold back for 20 minutes? I'm like, well, that's not really how we do this. And so you have to explain how it's done. So one of the tests that I'm sure you've seen is the HP White 5AA1. This was one of the first ones on the market. It came out right after Sandy Hook, as a matter of fact, and was designed by a glass manufacturer to quantify their product. The problem with that is it's a manual test and it is a not a certified test standard the way an ASTM standard is. ASTM standards are developed by committee with a particular outcome in mind. So when you're looking at different testing, having the most up-to-date test and the most rigorous test out there is important because you're not designing your uh, you're not designing your facility around a product. You're designing a facility around an outcome. And if you have a test that has, a specific outcome that doesn't, no matter what product it's tested to, that's where you want to be. Outcome rather than, having a product in mind. So which brings us back to the ASTM 3561. It filled in a lot of the gaps that were there with some of the other testing. It has a pass-fail criteria, but one of the things that we'll get into in the next slide is that it is not just a pass-fail. It is also it has levels like the UL 752. Let me get to that slide. Okay, so what you're looking at on the right is the actual contraption they use to shoot the glass. So the way this test is conducted, the glass is shot 10 times, 2 in the center, horizontal, and 8 in a circle. After the glass is weakened, those rounds are meant to go through. After the glass is weakened, they use the 100-pound pendulum going through 8 levels. So you start at level 1, which drops from 6 inches, and then you add 6 inches to each level, with the terminus being level 8, dropping from 4 feet or 48 inches, delivering 400 pounds of foot force. It's important to note that you cannot go out and just test to level 8. The test must be conducted sequentially. So if you've been to level 8, that means you have withstood 16 strikes on the glass with 10 bullet holes. So this is what they mean when they designed this test, this the active shooter test. The cumulative effect of this is you can see right there a total of 3,600 foot-pounds of force on the glass. And in our opinion, there's really no sense in talking about anything less than level 8. If you look at level 4, 200 foot-pounds of force, that's not a whole lot. That's not a whole lot more or right about equal to what just a normal person could exert with a 3 to 5 pound kitchen hammer. I did these are inexact numbers. I did some, AI calculations on this because it's hard to calculate what, the force that someone's going to swing. But roughly, level 4 is just a normal kitchen hammer. So it's not even worth talking about anything under level 4. And even level 8, when we get to the video here in a second, I've got someone testing our glass with a 12-pound sledgehammer, which is, double what level 8 would deliver. So it's important to keep that in mind because in the few places I have seen the 3561 mentioned, because it hasn't had wide adoption yet, it just says 3561. It doesn't give a qualifier as to what level it needs to pass to. And that's, essentially like saying UL 752 and not giving anything behind it. You've got, that's a large range. That's 9mm to 50 caliber rifle, armor piercing rifle. So it needs to be remembered that, this is not just as some of the other tests are a pass fail. It's got to be what level. And in our opinion, it's not even worth talking about unless you're testing it to level 8. All right, so this is a video of the pendulum contraption. they use for that. As you can see, the glass has been shot 10 times. Um, that is a mid-level. I think that was level 5 that they just tested that to. You can see the glass has already been fairly well broken from the previous strikes. This next video is level 8. So as you can see, the glass is pretty well broken, but what constitutes a failure on this test is if the glass is breached to the point where the nose of that, you know, pendulum torpedo can pierce through the glass. It's very similar to some of the other tests where you have a random object that they say, okay, if we can beat this glass to the point where we can get this, generally it's something that looks like a football. If we can put that through the glass, the test is a failure. It's very similar to this. If the nose of that torpedo breaches the glass, then it's a failure. And the way that works is, say you tested just fine to level 6, and then on level 7 it breaches. Well, then the test is a pass at level 6. It's got to make it all the way through both strikes. Let's go on to the next slide. Okay, so this is a video that we did in the field with a gentleman that we worked with who is a retired Army Ranger who had breaching experience. And we did this so we could, get some data points of our own. We also did it to show what our glass is capable of. But in this is a rough approximation, at least in the shot pattern, of the 3561. Except we're going to shoot it 12 times, and then we're going to let him attack the glass. I'm going to go ahead and hit play. This will go for 2-3 minutes. There won't be any sound. Again, those rounds are meant to penetrate. Those are not stopping. So here you have a kitchen hammer, roughly a level 4 on the 3561. And that is just a standard aluminum door. This is a retrofit. That's not a forced entry door. I believe that's a US aluminum door that, we fixed the glass in. So he's got a 5-pound handheld sledge there. I don't know what level that would equate to. Something over level 4, not probably quite level 8. That gentleman is hitting that with a 12-pound sledgehammer. And in the rough calculations I was able to do with ChatGPT, that's somewhere around 1,000 foot-pounds of force on that glass. So this is our school safe premium that he's hitting, by the way. We'll go over that here in a minute. But clearly, you need something that passes to level 8, because if these gentlemen had attacked something we had designed to get to level 4, they'd be through that door already. All right, I'm gonna go ahead and stop that. Go on to the next slide. Okay, so at the beginning of this, we were talking about security glazing solutions. There are really only 2, each one having subsequent, many things underneath them that are variations. There are different kinds of window film. Laminated glass, you can have laminated ballistic glass, which is kind of by default forced entry glass. And then you can have specifically designed forced entry glass. I mean, our thinnest forced entry glass is 3/8 thick, whereas, our thickest, ballistic glass is 4 inches. So there's a lot of variation within that. But the ones that the schools are employing now are either going to be some type of security film, which obviously we don't recommend, or some type of laminate, whether that be just interlayer or interlayer with polycarbonate, or low-level ballistic. There's a lot of things people are doing, but those are the 2 chief methods that they're using to both do new builds and retrofits for schools. All right, let's go to. So this is just a short video of us showing typical safety film installation. I'm not going to name the film type in this, but it is an extremely well-known film type, and it is specified all over the place as a forced entry deterrent. And look, I was in the film business before I got into uh, the ballistic glass business. That's how I made my living. I was just in the security film business, and it's better than nothing. But I didn't know just how much better ballistic or moreover forced entry glass is as a deterrent than safety and security film. Let me play this. So you can see he shoots it twice. That film is attached with the attachment system, fully cured out. He's able to make a wide hole in that and then punch the corner out. Gets on the exit device in 11 seconds. So this goes back to understanding the limitations and capabilities of what it is schools are both buying, specifying, because there's a lot of misinformation in the market. People routinely overstate what their products are capable of. And again, this isn't to say that that uh, certain products don't have their place, but understanding which ones are the best and which ones truly work needs to be conveyed to the educators because that's not the business they got into. These people didn't get into um, teaching children or managing ISDs because they wanted to be safety and security experts. I'm going to the next. All right, so which brings us to School Safe. School Safe is Ballistic Glass and Armor's line of school glazing. We have two different types. This was designed in response to the market. We were not the first product like this on the market. There's a few of us out there, but we started developing this about 5 years ago for some of the larger ISDs in North Texas. North Texas has some of the biggest and fastest growing school districts in the country. And over the last 5 years, we refined these products and we have what we call School Safe Standard, which is the 3/8 glass I was speaking about. That is passes to 3561 to level 8. And then we have the School Safe Premium. Everything I've showed you thus far has been on our premium, which is a 9/16 forced entry. It has one of the older standards from ASTM, the F1233. We also have the ASTM 3561 to level 8, and it is a UL level 1 penetration standard. The reason I qualify it that way is it is a low spall product, but it is designed to stop rounds from a 9mm. These are both glass clad applications. There's no film involved. They're not all poly makeups. So they can be used in a variety of applications, monolithically or insulated glass units. So we have a table here, kind of go over that, what I was just talking about. School safe standard, ASTM level 8, insulated, tented, low E, low iron. We can put tent into the actual monolithic itself. On a limited basis, we can do ceramic frit. Um, it's it is compatible with just about any kind of glazing system you can think of, is listed there. School Safe Premium, ASTM F1233, 3561 to level 8, and UL level 1 penetration standard. This is our most popular product because it is the sweet spot of forced entry. It can also be put into insulated glass units. It can be done in retrofit. You can use low iron. You can do, the tinted glass, ceramic frit. It also is, compatible with just about any type of door and framing system you can think of. Of all the schools in, North Texas we've done, this has been the most popular because it's the sweet spot between ballistic and forced entry protection. Behind an AR-15, the 9mm handgun, which is level 1, is the most common handgun, most common ballistic round on the planet. Probably 8 out of every 10 guns on the street is a 9 millimeter. So having that level of protection is a good midpoint without trying to build a fortress. All right. Oh, also, um, we have a limited warranty. It's fairly typical for the market against defects and 3-year market warranty against delamination. We also are the only company in the marketplace that has the forever safe warranty. So if there is an attack on the glass, whether it be a forced entry or ballistic attack, and that product does its job and stops the would-be assailant, we will replace that glass, for the life of the project. So there's obviously exclusions on that, but if somebody's looking at a project and said, well, what if this gets broken or somebody tries to come in, it's expensive to replace. That's something we offer because of how confident we are in the product doing what it's supposed to do. Lastly, on this one, we have the best lead time in the industry. Most of the other of our competition is it anywhere from 8 to upwards of 16, 18 weeks, depending on the time of year. Um, we have a 4 to 8 week lead time, obviously, also with limitations. If you dump a massive project on us, that will have to go in stages. But just for a typical garden variety project, we're a 4 to 8 week lead time. And again, I'm fairly certain we're the best in the industry. And I know that we also have one of the best on-time delivery records in the industry as well. We keep track of that internally, and last year we closed out 24 with a 95% on-time ship date. So just to kind of go over some of the projects I was talking about, this is just a sample. And again, most of these are in North Texas, but this is our backyard. This is where we developed these, and this is where we have the most penetration with both glazers and architects. We have shipped all over the country. Some of my biggest clients are in the New York metro area, but most of those projects are not on the scale of the ones listed here. So, take the one in the middle there, Frisco Independent School District. It's 80 plus schools on that. Lee Summit I apologize, that is a typo. That's Lee Summit, Missouri, not Texas. But, we're in the process of doing 24 schools for them. So it has been widely specified by some of the larger school-centered architectural firms, again, especially here in North Texas. But, you know, being that there's only a few people doing what we're doing, we do ship this all over the country. Okay, why BGAS? So we're not just, the school glass is not just what we do. We are also, like I said earlier, full service glass fabricator. We were born out of a company that was in business to produce replacement glass for military vehicles. We produce everything on the UL 752 schedule from level 1 to level 10. And we've been in business 7 years now. We've had several marquee projects as well of just garden variety ones. We did the police station at Times Square, did the entire facade of that building. We've done some work at Fort Knox, and as it says, everything in between. One of the other things about us versus some of the other security companies out there is most of the security companies on the market are selling some type of framing or door system, and the glass they source separately. We are a laminator first. We do offer some armored aluminum systems. We have some other products I'll get into in a minute, but the majority of who we are and what we do is glass fabrication. And why that's important is that we control the process. So if something needs to happen, if we need a rush order to get a job finished up, or if there's something that is extremely detail oriented about it, you can see our water jet right there. If we're having to water jet shapes, or you're dealing directly with the person who's making the glass, so there's no risk of anything being lost in translation. So we're very proud of that, and it shows in the quality of our work. And go to the next slide. Okay. We're also, as I said, continuing to innovate and bring out other products to the market. What you're looking at there on the right is what we call our Defendor, which is it's an all glass level 3 ballistic door. Um, that is a purpose built door. There's nothing on that you see other than the pulls that we didn't design ourselves. The rails, everything about it, that's our glass clearly. So we're not shoehorning our glass into a CRL rail. It's a purpose-built design. And why we did this is, as along with schools, there's a heightened sense of insecurity in the market for executives. And that, obviously with the tragedy that just happened with the United Healthcare CEO, there are trends in the market that are not good. But these type of people and these type of uh, settings require something other than a typical ballistic glass installation. Um, you know, like this client, the picture you're seeing, that is an actual install for a very well-known sports gaming company. Um, and they wanted to retrofit their main entrance. We did several other entrances for them as well, but they don't own the building, and the building owner would not allow them to put something that didn't meet and match the current aesthetic of his building. So everything you see in that picture is ours. That's our glass on the side lights. That's our framing. That's our framing, like our framing that's cladded with brushed stainless. So just to give you an idea of the depth at BGAS, we're not just a glass fabricator, we're also innovating and bringing new products to the market. I guess that's it. Happy to take any questions.
So let me unpin you real quick, Hunter. All right. So thank you for a great presentation. We do have a few questions coming in right now. I encourage anyone else, if you do have questions, now is the time. But let me go ahead and read off a couple that we do have coming in. All right. First, we've got, are these tests similar to tests performed for wind and projectile protection in storm or hurricane?
So those are all separate. Those are all separate ASTM tests. Um, like the windborne debris, what they use for that is they call the large missile test, where they fire a 2x4 out of a cannon going a certain amount of feet per second. That is, the windborne debris. It's different from wind load, but hurricane testing is different than the 3561. The 3561 does have a provision for system testing, but it also has a provision for component testing, which is what we did with this glass, because it's chiefly used as a retrofit product, honestly. And the other distinction is that hurricane glass, those applications have got to be, my understanding, because this is not my arena, but I know enough about it that, it's the wall system tested with the framing system tested with the glass. So there's no reason that we couldn't test to that for the glass, but we don't have our own hurricane framing system. So hope that answers your question.
Yep, that makes sense. Awesome. Next, we have, what are the size limitations for an individual site? Are there minimum frame byte dimensions?
Size limitations. Okay, I'm going to take this one at a time. So the school safe standard is a thinner glass. And so we kind of cap that at probably 60 by 96 on that, simply because that glass you start getting too much longer than that, and you run the risk of it breaking under its own weight due to the fact that it'll sag. And if you tempering 1/8 inch glass, you run the risk of roll wave distortion. So we try and keep it small. Um, on the School Safe Premium and our other makeups, it is 60 by 120. Most of the manufacturers are capped at 60 by 96. one of the reasons that we have to stay at 60, just there's very little, if any, supply of polyurethane in the market that has a roll width of greater than 60 inches. They just don't produce that anymore. So we're kind of limited by that. And what was the second part of that question?
Second part was, sorry, let me find it. Are there any minimum frame? I think this maybe means bit, but it says
Yeah,
bite number.
bite. It's the bite of the frame. That's what I thought. So
Okay.
it's pretty, congruent with just normal. I mean, like, we recommend a minimum of 3/8 inch bite all the way around.
Okay. Wonderful. We do have some more questions coming in. All right. Next one is pretty simple. Do you ship to Canada?
We do. It's been a while since I've done a project up there, but we absolutely do.
Perfect. 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 How does the ballistic glazing compare to high impact hurricane glazing systems? So similar to that one we had before.
Well, I am not super familiar with the composition of the high impact hurricane glazing systems, but I am like our product is a glass clad polycarbonate. Um, Most of those impact glass applications are made with PVB or Sentry glass, meaning it's just, two pieces of glass laminated together with some amount of either of those products in between to bond them together. And honestly, those are built almost to hit like a trampoline, kind of flex in, hold together, and bounce out, uh, not to be subjugated to repeated um, sharp strikes like you would have from, say, a hammer. So they're similar in the fact that they're laminated glass, but the glazing used in hurricane applications is generally a more commoditized, thinner product like 5/16 Lamy.
Okay, good to know. Next we have, are there any considerations for specifying in colder environments such as climate zone 6 or 7 for this type of glass?
Um, no, I mean, we sell, like I said, we sell all over the country. I've got stuff in Minnesota, New York. You know, the only consideration would, just be kind of the same consideration you'd have with other glass products for thermal cracks, where you've got uh, you know, a cold frame with hot sun heating up the glass, but it's not there's nothing keeping this glass from being installed in an extremely cold or extremely hot climate.
Perfect. All right, we have a few more. What would be the ballistic protection inserted in case goods furniture, for example, banks?
Say that, ask that again.
What would be the ballistic protection inserted in case goods furniture, for example, banks?
I mean, banks, I mean, I've got some dedicated banking customers. Um, they tend to go with level three. Most of what I do for those guys is drive up transaction windows like the motor bank, and they all do level three. Um, I'm sure there's some people that do higher than that, but you're going to find that outside of, if you're talking strictly the ballistic glass market, take the forced entry part out, you're going to find that the ballistic market is probably close to 80% level three.
Okay, perfect. All right. Well, next we have, are there glazing tinting options?
There are. So, we're limited by, what say vitro, people like that manufacture. But, I've got a project right now that um, I'm doing some gray tint. We've got, that Frisco school that was on the one of the previous slides. We have three different kinds. We got, a blue glass, a green glass, a gray glass. There's nothing keeping us from laminating that. It's just what is available at the glass thicknesses we're using is the constraint.
Wonderful. All right, we've got, In a previous project, exposed black caulking was needed. How is your glass currently installed in a frame system?
So the exposed glass caulking is the attachment system for security film. So security film is an overlay over existing glass. You put it to the edges of the glass behind the daylight opening. And then in order to keep it in place, because if you just put security film up and somebody hits it, what you're going to do is you just have one piece of glass fall out. But in order to keep it from doing that, you use something like a Dow 995 structural silicone, which has to have a half-inch bite on the frame and a half-inch bite on the glass. So that is the black caulking you're talking about. So it's got a 1-inch sight line. So in addition to not being as effective as laminated glass, it detracts from the looks of the installation as well. With our forced entry glass, um, you can just use like a clear 795 to the interior, but even then it's not necessary for you to wet glaze the interior. I mean, if you can fit it in the pocket with the gasket, then you don't have to wet glaze at all. Our School Save Premium in an IGU gets a little thicker, so typically you'll use the gaskets on the exterior and then just do a wet glaze on the interior. So you do not have that black caulk line.
Excellent. Thank you for that. All right, last question we have is the glass ever tested for vehicle impacts?
No, that's that vehicle glass is something we just don't get involved with. Um, there are a lot of big players in that business, and in order to get into the ballistic, or sorry, this type of application for a vehicle, you'd also have to be able to bend the glass, which we are not able to do.
Gotcha. Yeah, that was very helpful. And that was our last question. So I dropped that link to Ballistic Glass's Acelab page in the chat. You can go there and get in direct contact with Hunter after today's session. Um, Otherwise, thank you everyone for joining. Thank you,
Thank you all
Hunter.
very much for taking the time to join us today. I really appreciate it.
Awesome. Everyone have a great day.
Too.
Thank you. Bye.